So in this question we have an equation y is equal to x squared ln x divided by 3 minus 2x plus 5. This is curve C, and part of this is shown here in figure 4. And we can see the parabola-like shape there, and then we have a finite region S, which we can see is shaded here, and that has the lines x equals 1 and x equals 3. So in part A of this question, we're asked to use the trapezium rule with all of these values given in the table to obtain an estimate for the area of S, and we're asked to give our answer to 3 decimal places. We can work out the area using the trapezium rule by doing 1/2 times by h, where h is the width of each bar, and then we're going to have big brackets, and we're going to have y0 plus yn, and then we're going to add this to 2 lots of y1 plus y2 plus all the other y's all the way up to y of n minus 1. Then we close our brackets. So this is the trapezium rule. So there's a few bits of information we need to be able to carry this out. So we need to work out what h is, and then we need to work out y0, yn, and all these other y's along the way. So we'll first look at how to work out h. So as I said, what h is, it is going to be the width of the strips. And we can work this out by looking at the difference between each value of x given in the table. So we can see here we go from 1 to 1.5 to 2 to 2.5 and to 3. So we can see here that each difference is 1 over 2. So we're adding 0.5 each time. So therefore, writing it down potentially more mathematically, we'll have that h is going to be equal to 1.5 minus 1. And it's also going to be equal to 2 minus 1.5, etc. And we know that these all equal 0.5. So therefore, we have that the width of each strip is going to be 0.5. Then we have that y0 is going to be this first value of y here. So we'll have y0, then we'll have y1, y2, y3, and y4. So that then means that we can use our formula. Now that we have all the required information, we can say that the area is going to be equal to 1 over 2 multiplied by half. So writing that in a fraction terms as well, we're going to have 1 over 2. And then we're going to multiply this by 3, and then we're going to add that to y of 4, which is going to be equal to 2.2958. And we'll just put our brackets in just to keep everything straightforward. And then to this we're going to add 2 lots of 2.3041 plus y of 2, which is 1.9242. And then we have y of n minus 1 is going to be y of 3, which is going to be in our case 1.9089. Then we close our big brackets, and then we put all of this into the calculator, and we get that the area is equal to 4.39255. So for calling the question, we're asked to do this to 3 decimal places. So we therefore conclude that the area of S is 4.393. And that answers to 3 decimal places. So in question B here, we're asked to explain how the trapezium rule could be used to obtain a more accurate estimate for the area of S. So firstly, what is h? This is going to be useful for this question. So h is the width of the intervals. So we can have a think, what can we do to h to give us a more accurate estimate for the area of S? So when we think about it, when we split our graph up into lots of different strips, we know what we're doing is we split the area into a number of different strips or trapeziums, and then we work out the area of each trapezium, and then that gives us an estimate of the overall area. So what we can do to get a more accurate measurement, we have two options. We can decrease the width of the strips. So this means that option 1, it's going to be to decrease h, or in other words, the width of the strips. And when we do this, it means that each strip fits a little bit more area into it, which means that less area is being missed out and the estimate becomes more accurate. And then we have a second option, option 2, and what it's going to be, it is to increase the number of strips. So in theory, if we add in more strips, this is going to give the same effect as decreasing the width of the strips. So just noting that down there, we could also increase the number of strips. And by doing either option 1 or option 2, we will therefore obtain a more accurate estimate for the area of S. So in part C of this question, we're asked to show that the exact area of S can be written in the form A over B plus ln C, where A, B and C are integers to be found. So if we recall back to the earlier part of our question, we were given an equation of curve C, and we'll recall that y was equal to x squared ln x divided by 3, then it subtracted 2x and added on 5. So then from our knowledge of integration, we can then say that the area is going to be equal to the integral of y, which is x squared ln x, and we divide that by 3, then we subtract 2x and add 5. So here you can see our graph on the right hand side of the page, and we can see that the region S goes between x equals 1 and x is equal to 3. So therefore our limits are going to be 3 as the upper limit and 1 as the lower limit. So now we need to have a think and see how we go about integrating this equation. So we know that integrating negative 2x and 5, that's something that we know we're capable of, and it's going to be straightforward to work that through. But then we have the term x squared ln x divided by 3, and this is going to pose us a bit of a difficult challenge, and we'll need to think of a technique that we know to be able to integrate this. We would have options such as integration by substitution, but it will not work in this case, so we have to use integration by parts. And we recall the integration by parts formula. So we'll have that the integral of x squared ln x all divided by 3, and integrating it with respect to x is going to be equal to f of x multiplied by g of x. Then we're going to subtract the integral of f of x multiplied by g dash x. And we integrate this with respect to x. So now what we need to do is we need to assign an f of x and a g of x. So what we're going to do is we're going to let f dash of x be equal to x squared over 3. And then we're going to let g of x be equal to ln of x. So then what we can do is we can work out f of x, and we do that by integrating x squared over 3, and this comes out as x cubed divided by 9. And we can then work out g dash of x by differentiating ln x, which we know is going to be 1 over x. So therefore, we can then do our integration by parts by taking these expressions here and substituting them into our formula for integration by parts here. So therefore, still working with the integral x squared ln x divided by 3 with respect to x, it is going to be equal to x cubed over 9, which is our f of x term, and we're going to multiply that by g of x, which is ln of x. Then we're going to take away the integral of x cubed over 9, and we multiply that by 1 over x, and it's with respect to x. So then our next step here, we can keep the first part of it as is, x cubed over 9 multiplied by ln of x. Then what we see here is we have x cubed over 9, and that has been multiplied by 1 over x, so that is going to be equal to subtracting. We can take out 1 over 9 as it's just a number, and we can scale our integral by it after. And then we still have our integral, and this time we're going to have x cubed divided by x, which is going to be x squared dx. So now we have something we know how to integrate. So we can integrate x squared, and then we have the following. So we'll have x cubed divided by 9, then we'll have ln x, and then we know that this is then going to be negative, then it's going to be 1 over 9 multiplied by x cubed over 3, which is going to come out as x cubed divided by 27. And then just for completeness, we'll add c because we've integrated without a constant. So as you can see, I've now worked out what the integral of x squared ln x over 3 with respect to x is. So this means I can come back to this equation up here and now integrate negative 2x and 5, and then that will mean we've worked out the area. So I'll do this as follows. So therefore, the area is going to be equal to the integral of x squared ln x all divided by 3, and then as we know, we subtract 2x and we add 5, that's with respect to x. So therefore we have that the area is going to be, so we've just worked out what this integral is in here, so we'll copy this down there. So we're going to have x cubed, we divide that by 9 ln of x, and then we subtract x cubed over 27, and we don't need to add c because we're about to deal with our limits. So we can now take a look at the term negative 2x. So we need to think, what's this going to integrate to? So we know it's going to integrate to negative x squared, and then we have that 5 is going to integrate to 5x with respect to x. 5x, and then now we've done our integration, we'll put these square brackets in and we'll write down a 3 and a 1 here, as they're still our limits, so we can't forget that. So now what we need to do is substitute in our limits 3 and 1 into this expression for x, and then we can see what the area is, and this is called evaluating a definite integral. So this is going to be equal to, by first taking our upper limit 3 and substituting this in, we're going to have 3 cubed divided by 9, and we multiply this by ln of 3, and then we're going to subtract 3 cubed over 27, and then we subtract 3 squared, which is going to be 9, and then we add 5 times 3, which is 15. Then we'll put our square brackets in here just so we can keep track of things. And then we're going to subtract the same, but with 1 substituted in for x, which is going to give us 1 over 9 ln of 1. And then we're going to take away 1 over 27, and then we'll have subtracted 1 and plus 5. So we can now tidy this up, and what we'll have is, we see that 3 cubed divided by 9 is going to be 27 over 9, which is 3. So we'll have 3 ln 3, and then we subtract 3 cubed over 27. We know that 3 cubed is 27, so 27 over 27 is going to be equal to 1. So we subtract, just write this in here, we'll subtract 1, then we'll subtract 9 and add 15. So putting this into our calculator or doing it in our head, we know that this is going to be equal to 5. So we add 5, and then still being careful with our brackets, we'll then take a look at this second half. So we know that ln of 1 is going to be equal to 0. So therefore, this term here is equal to 0. And then if we take these three terms here and add them together, that comes out as 107 divided by 27. So this then means copying that down here, we'll then subtract 107 over 27. So this then means we'll have that the area of S is going to be equal to 3 ln of 3 plus 28 over 27. And then looking just back to the question to see what we're aiming for, we're asked to write something in the form a over b ln c. But unfortunately so far, we have a constant in front of the ln. We have the following log power law, such that a ln of b is equal to ln b to the power of a. So what we can do here is we can take our 3 here and put it as the exponent of 3, and we know that 3 to the power of 3 is going to be equal to 27. So then that means we can take this one step further and write that a is equal to ln 3 to the power of 3, which is 27, plus 28 over 27. So therefore we can say that a is equal to 28, b is equal to 27, and that c is equal to 27 also. And in conclusion, we then have the exact area of S, and this is written as ln 27 plus 28 over 27. So we'll now take a look back at where the marks were on offer. In part A of the question, there was 3 marks on offer. So we received our first mark for working out that h was equal to 0.5. So this was finding the width of our trapeziums. Our second mark was having the correct form for the trapezium rule. So this means having the equation written out as we have here in the first line. And then the third mark on offer was given for substituting all these values into the right equation and concluding that the area of S using the trapezium rule is 4.393. Then taking a look at question B, we were just given 1 mark for having the correct conclusion. I've included 2 options here, but to receive the mark, you only had to include 1. And now taking a look at part C of this question, we received our first mark for knowing to do integration by parts. We then received our second mark for getting the integration by parts into this form here. So x cubed over 9 ln x, take away the integral of x cubed over 9 multiplied by 1 over x. So that's where we got our second mark. We then got our third mark for correctly integrating this and getting to this stage down here. We then receive our fourth mark for doing all the integration correctly and getting to this stage here where we're ready to substitute our limits in. And then we received our fifth mark for correctly substituting these limits in and using these log laws. So knowing to make 3 ln 3 into ln 27. And then we finally receive our sixth and final mark for concluding with the area of S and then stating what A, B and C were.